Hi, sorry. I was running late this morning. I'm going to turn off one of those lights. You know what? It might be fine. Do y'all see the glare when y'all are doing at home on the board? Oh, you haven't really seen it? Maybe I just see it when I'm looking at it. Okay, so what this section is on is inverse functions. Okay, an inverse means you're going to switch the x and the y of the function. Okay, so when you're looking at problems like number 1, and it just gives you a group of points, okay, like this one gives us the points -9, 5, -7, -1, -5, -3, and 5, -5. So when it just gives you a group of points and asks you to find the inverse, you just simply go to each point and flip-flop its x and y. So this one would just flip-flop to 5, -9, and then the rest of the way down. This one would be -1, -7, -3, -5, and -5, 5. So you're just switching the x and y. So number 2 is same kind of thing. I have an equation this time. And in the equation, I have x to the 3rd y equals -5. And it wants you to find the equation of the inverse relation. So just like I did on these, all I'm going to do, the equation of the inverse, is just switching the x and the y, which means I will have y to the 3rd x equals -5. So again, you're just inverting the x and the y. Okay? Now, remember when we were looking at graphs and deciding whether or not they represented a function or not, we used that vertical line test, right? And if the vertical line only touched the shape of the graph one time, then it was a function. Y'all remember doing that? So now there's also a line test to tell whether or not the function is one-to-one. And what that means, it's kind of like the opposite of, or in taking a function further, is all the range numbers only correspond to one domain number, okay? So the test that you use for that is the horizontal line test, right? And horizontal lines are these lines, the one that's like that. So when we have a graph, to see if it's 1 to 1, you're going to perform the horizontal line test on it to see if the horizontal line only touches the function once. So let's look at some of these. Okay, so we're talking about the horizontal line test, which tells whether or not your graph is 1 to 1. And just like the vertical line test, you're looking for that horizontal line to only touch your graph once to see if it's 1 to 1. And the reason we want to see if functions are 1 to 1 or not is because only 1 to 1 functions have inverses. So when we start finding inverses of functions here in a little bit, the first thing you're going to have to do is see if whether or not they're 1 to 1. So let's look at some of these. Okay, and I'm going to put all 4 of these up here at the same time so we can look at the difference of them. So numbers 3, 4, 5, and 6. There's what 3 looks like. 4 looks like that. 5 looks like that.
Ms. Hanson, which worksheet are we working from?
9.2. Didn't we do 9.1 on Monday? No, I have myself on. Should look like.
Yes, ma'am.
Okay. So that's problems 3, 4, 5, and 6, what they look like. So all you're doing on all 4 of these problems is going through and performing that horizontal line test on them. Okay, which means I'm going through and drawing a horizontal line everywhere. If I draw it right here, is there anywhere that you could draw a horizontal line on this graph and touch that shape more than once? No. All those horizontal lines are just touching that green graph one time. So yes, this one is 1 to 1. But this one, if I draw a horizontal line right here, it touches it 1 time, 2 times. So that one is not 1 to 1. Same with this one. You draw it here or here. Either way, anywhere you draw it, your horizontal line is touching that graph more than 1 time. So that makes it not 1 to 1. And the last one like this. Again, it's just, if you draw a horizontal line, it only touches it 1 time on number 6, right? Won't touch it more than once. Yeah.
I'm confused on what you were trying to say. Like 3, 4, 5, 6.
So I just wrote them all the problems from the homework that went over the horizontal line test, I just did them all at once instead of writing them up there separately, because you kind of learn from each of them what makes it. So when you go and do your homework, right, it's going to look like your individual problems are going to look like that. So all I did was put these 4 problems up there all at the same time.
So,
And then use the horizontal line test on them. Right here.
yeah, but I'm just confused on what's one-to-one function.
Okay, one-to-one functions means that each element in your range, it's kind of backwards. Each element of your range only corresponds to one element of your domain, which means each of your y's will only go to one x. And only what we're about to do now is find the inverse of some functions, which means I'm going to switch their x and y. You can only do that with one-to-one functions. So what you have to do first, before you find the inverse of a function, is make sure it's one-to-one. Like on number 7, it said the first thing it says is for the following function, first determine whether it's one-to-one, which means I need to see what it would look like on a graph. So on number 7, it says for the function f of x equals x plus 8. It says first of all, determine whether or not it's one-to-one. So remember, that's the same thing as saying y, right? So I'm taking this to my y equals and putting in x plus 8. So if I go to y equals and clear it out, so again, I'm on my y equals button and hit clear, make sure there's not anything in there, and then just type in x plus 8. Remember, your x button has all those letters on it, the x, the t, and all that. So x plus 8. And then graph it, right? Because what I want to do is see what shape it is. Well, it's just a line, right? If I graph this, it looks somewhat this isn't exact, but it gets the job done, right? It looks somewhat like that. Does that pass the horizontal line test? Yeah. It does pass the horizontal line test, which means I can find its inverse. Here are the steps to find the inverse. So the steps to finding the inverse, the first thing you're going to do is just change this f of x. Remember, f of x and y are the same thing, so just write it as y. Then after you do that, like we did on number 1 and 2, you're going to switch the x and the y. Once you switch the x and the y, then wherever your new y is, you're going to solve for it, which means get it by itself. Okay, so let's do that with this one. So I need to, first of all, write that as a y. So I'll have y equals x plus 8. So once I make the f of x and y, then I'm gonna switch the x and the y, which means now I'll have x equals y plus 8. The last step is to now solve for the new y, which means now where your new y is, get it by itself. So if I want this y to be by itself, I just need to get rid of that plus 8 by subtracting 8. So that's gone. Now I have y equals, then this side would be, I can't put those together, right? It's just going to be x minus 8. Okay? And the way that you write inverse, and they have it done there for you, is f to the negative 1 of x. That means the inverse of this function is this. All you have to do is type in that x minus 8. Okay? So again, these 3 steps. Change f of x to y, flip-flop your x and y, solve for the new y. Let's look at another one. Number 8. Oh, sorry, go ahead. Oh, I was such a hurry to get out of my car with my water up there. Ready? All right, number 8. Again, it's going to ask if it's one-to-one first, right? Only one-to-one functions have inverses. And I'm going to go ahead and tell you, all the ones in this section are going to be one-to-one. They're all going to have inverses, right? We want to practice writing the inverse. But you would check it. So I would put 4x minus 6 in my y equals. To graph it. Oops. And again, when you graph that, once again, it's just another line, right? That one looks like that when it's on the graph. Which just means I do the steps to find its inverse. What's the first step? The first 2 steps are not bad at all, right? You're just rewriting it first. And that needs to be written as a y. Now that you see your y, now what do? Flip-flop them. Switch the x and the y. That's exactly right. So now I'll have, there's my x equals 4y minus 6 get your new y by itself. Which means the first thing I need to do, remember when you're solving an equation, whatever is hooked on to what you're trying to get by itself always goes away last, right? The thing that's hooked on to that y is going to hang on until the very end. So the first thing I'm getting rid of is that minus 6 with a plus 6 to both sides. So over here on the left, I can't put those together, right? They're not like terms. So you have an x and a plus 6, which is just that, x plus 6 equals, the only thing left over here on the right is 4y, so I'm getting closer to my y being by itself. The only thing that's left is that hooked on 4. And to get rid of numbers that are hooked on, you divide. So the 4's cancel. There's my y equals, which means this side is my inverse. And I can actually write it just like this. X plus 6 over 4. Put in your calculator that in your first y equals and this in your second y equals. When you're putting this in your second y equals, I'm pretty sure, I think you need to put so that it'll tell this all of that whole x plus 6 to be your numerator. Put that x plus 6 in parentheses before you put it over, then hit the divided 4 button. So it should look like this. You should have 4x minus 6 in your first y equals. That's what gave me, here, I'm gonna write it. That first graph that looked like that. Then in the second y equals, again, put the x, do open parentheses, x plus 6, close parentheses, then hit divided by 4. So since you put it in the second one, it's going to graph this line and this line on the same coordinate plane. And look how they look with each other. What inverses do? So it looks something like that. What inverses do is they are what is called symmetrical across this. If you drew a line right here, and folded it on that red dotted line, the inverses will lie on top of each other. Okay? If this line is the equation y equals x. That red dotted line is, it cuts your coordinate plane. It goes right halfway through this coordinate and halfway through that coordinate. Inverses, if you have a sheet of paper and you folded it on that red line and you had inverse functions on there, once you folded it on that red line, the two functions would lie on top of each other. Clear all that out and type in 4x minus 6 in your y, in your first y.
4x minus 6.
Mm-hmm.
Then what?
And then go down to your second y and do what you had. Do open parentheses,
Okay.
x plus 6, close. Then hit the divided by button. And then hit the 4.
Okay.
Now graph it. You have these two lines right here.
Well,
See, so if you don't have the red line, you could put the red line on there. This line right here is just what cuts the coordinate plane right in half. It cuts this whole, the black lines, it cuts them right in half right there.
okay.
You don't see it. If you wanted to see that on your graph, you would make one of your y equals, just say y equals x. That would put that red line on it, but won't be red.
Okay.
Okay, let's look at another one, number 9. And that was just to show y'all something that I think is cool, that you're not doing this anywhere. I was just showing you what happens when you have two inverses. Okay, this is your answer to that problem. That's the inverse. So now let's look at number 9. Number 9's function is f of x equals 3 over x plus 9. So, if you wanted to check it, put it in your calculator. But it is 1-to-1, so I'm going to turn this into a y. Now what do I need to do? Flip-flop them, right? So now I have x equals 3 over y plus 9. So this one takes a little bit of work to solve because what are you trying to get by itself? Your new y, which is right here. If what you're trying, first of all, we don't like crazy looking fractions like that anyway. So remember the other day or Monday, so y'all were probably at home when we had the x in the denominator of that crazy fraction. So we multiplied the top and the bottom by x. What I want to do is get rid of that y plus 9 to make the y not be in the bottom of a fraction. That also is going to take care of having fractions in this whole equation. So whatever this denominator is, multiply both sides by it. In fact, the reason is, look what's going to happen on this side. What's this y plus 9 going to do? It's going to cancel that one because I got a y plus 9 in the top and a y plus 9 in the bottom. So it's going to cancel it. Now, since I did do it on this side, I have to do it over here also, right? That's the rule of equations. If you do it to one side, you have to do it to the other. So this y plus 9 cancels that one. All I'm left with over here is 3. Now, over here, this y plus 9 goes to with this x, right? This x is bumping up against it, which means I do need to distribute it. So when I multiply it times x times y gives me xy plus x times 9 is 9x. So now here's the y that I'm trying to get by itself. At least it's not in the bottom of a fraction anymore, like it was in the beginning. So now I just do my equation solving steps to get this y by itself. Remember, the hooked on thing goes away last. So the first thing I need to do is get rid of that plus 9x with a minus 9x. So let's see, I still have xy. I'm just going to write it up here now so I'm not getting up. So on the left side, all I have is xy. So that's gone. Then I have equals, and then I have this 3 minus 9x.
Negative x plus 9.
Or negative 9x plus 3, if you wanted to write
I
it.
mean, plus 3, yeah.
Yeah, absolutely, you can write it that way. Negative 9x plus 3 would also work. So for this y to be by itself, who needs to go away? The hooked on x. If you're hooked on, you go away by dividing by you, right? If that said 2y, you would divide by 2, right? Well, it just says xy. So you're just going to divide by this x. Everybody. So what are you left with here? There's your y all by itself. So that's what you wanted, to get the y by itself. Can you do anything to simplify 3 over x? No. Minus. What happens to these x's though? They do cancel, so all you're left with is the minus 9. So if you did put this as negative 9x plus 3, these two things would just be flip-flopped in your answer, which is totally fine also. All right, number 10. I think that was probably the hardest one. F of x equals x to the third minus 5. So this is a cubic function, which is 1-to-1. All cubic functions have some sort of that shape. Okay, that shape will pass the horizontal line test. This is, if your x cubed is your function, it's going to look like that, which would pass the 1-to-1 test. Which means I need to do the steps to find the inverse. This really says y equals x to the third minus 5. Flip-flop them. So x equals y to the third minus 5. Getting this y by itself. I know how to get rid of minus 5, right? I've been doing that this whole time. So to get rid of the minus 5, I'm just going to add the 5. So over here on the left, I have x plus 5 equals. Over here, I still have y to the third. So what I have to do is figure out how to get rid of that third power. So here's what you do. Remember, to knock stuff out, you do the opposite of it, right? The reason we added 5 is because we wanted to get rid of a minus 5. You do the opposite of it. That's what knocks it out. If we have 3x equals 6, to get rid of the 3, since it's times x, what's the opposite of times? Divide. So what I have to do is figure out what is the opposite of raising something to the third power. That's what's going to knock out that third power. The opposite of raising something to the third power is taking the cube root of it. That's the opposite of raising to the third power, is to take the cube root of it. The cube root knocks out the cube power. They're opposites of each other. If I take the cube root of this side, what else I got to do? Same thing over here. So I just cube root both sides. So let's see. On the right, the whole reason we did it is this cube root knocked out that cube power. So whatever your exponent is, that's the root you do to knock it out. So if it would have been to the fourth power, we would have used the fourth root to knock it out. Whatever exponent it is, you use that root to knock it out. So that knocked it out over here. Now this side, I can't do anything with that. I'm just left, there's my y. Over here, I just have the cube root of x plus 5. All right, number 11. You have f of x equals 3x squared plus 2. Then it says over here to the side, where x is greater than or equal to 0. We'll see why they're saying that. Because this is an x squared graph. If you're an x squared graph, you're going to make a u, aren't you? Aren't that what x squareds make? Is they make what's called parabolas. Let's graph this one first, because I'm thinking that's not going to pass the horizontal line test. If I'm a u, I'm going to have a horizontal line go straight through it and touch it twice. So let's see what this looks like on the graph. Type in 3x squared plus 2. It is a U shape, which brings why they put this on this problem. We haven't seen it before, right? When you type in 3x squared plus 2 and graph it, you get a U shape. It looks just like this. The reason it says where x is greater than or equal to 0, let's think about where that is on the graph. Here's my x-axis, right? Here's where x is 0. X is 0 all right here, right? If you are lying on this y-axis, it's because you haven't gone left or right at all. That's why your x is 0. So it's only wanting you to look on the right side of this graph. It only wants you to take into account that part of it. That's where the x is greater than 0 on that graph. So since it's just talking about this part of it, that part does pass the horizontal line test. So that's why you do find the inverse of it. So
it's not a 1-to-1, but you can find the inverse.
right, because it only wants you to look at this part of it, which is this only the right portion of it. So rewrite it as y equals 3x squared plus 2. Flip-flop them. So x equals 3y squared plus 2. And solve for your new y. So the first thing I want to do is get rid of that plus 2 out to the side. So I'll subtract 2. So now on the left, I'll have x minus 2 equals 3y squared. Now I can get rid of that 3. That 3 is hooked on. So how do you get rid of hooked on numbers? Going to divide by it. So I still have y squared. Over here, I just have a weird looking fraction, x minus 2 over 3. Now remember, how did I knock out the exponent on the last problem? I did whatever root the exponent was. So since it's squared this time, I will just knock it out with a square root. If I do that side, I have to do that side. So again, the squared and the square root knock each other out. This whole thing over here, you just can't simplify that. That is your answer. Square root x minus 2 over 3. Now, I will tell you on this one, look how it gives you, all you're typing in, it gives you this part right here. When you're typing in your answer, it gives you this part. Gives you all that. So all you're typing in right here is that x minus 2. It types in the rest of it for you. It just gives you a blank right there to put what you had in the top of that square root right there. So it tries to, I guess, give you a little something. Bless you. All right, last one. So remember what we just did there. We had a squared and we knocked it out with a square root, right? So when we're looking at number 12, f of x equals square root x plus 6. Oh gosh, sorry. This is 1 to 1. So let's rewrite it. Y equals square root x plus 6 switch the x and the y. So x equals the square root of y plus 6. Now, I can't do, now, because here's the y I'm trying to get by itself now, right? It's like it's trapped in that square root. I can't start doing anything with that plus 6. Because that plus 6 is underneath that radical. It's like it's being held hostage in there. So the first thing I have to do is remove that radical so I can get to what's inside of it. So remember in the last problem, we had a squared and we knocked it out with a square root because they're opposites of each other. They knock each other out. So what am I going to knock out a square root with? What's the opposite of it?
Squared.
Squared, right? Squared and square roots are opposite of each other, which means to knock out this square root, I square it. If I do that side, I got to do that side.
So x squared equals 6.
So x squared, so this squared knocks out that square root. It's kind of like it just releases what's in your radical. So I still have y plus 6, it's just the square root thing that went away. So if now I can move stuff around because it's not trapped in a square root anymore. If y is going to be by itself, all that needs to happen is get rid of the plus 6 with a minus 6. So that goes away. There's my y alone. All that's left over here on the left side is x squared minus 6. Okay, so I think I got everybody on line. I got Destiny Todd, Andrea Palos, Crystal Keys, Krishana Bennett, Stacy Ellis. Jackson Hauser, Jamie Bro, Gretchen Hines.
Yes, ma'am.
Okay, so I'm gonna